We are going to continue from question number 4, and step by step, we are going to solve harder and harder questions, okay? So our objective here is to bring you to the points, okay? Bring you to the point where you can solve the homework questions. So each following question is going to be a little harder than the previous one. Consider the following joint probability density function, it says. So we have two random variables. Again, both random variables here can also take values within the 0, 1 interval. So they can only take the values in the unit interval from 0 to 1, and they cannot take any other value as well. So the domain of this distribution is again bounded to the unit square. Now, we have the joint probability density function defined as 12x squared and y to the power 3. It says compute the probability of x being less than or equal to y. So this time, the question is not asking an individual probability statement that just belongs to x or any individual probability statement that just belongs to y. Instead, it asks us a joint probability statement related to both random variables. What is the probability of x to be less than or equal to y? Okay. Now, how are we going to solve that probability? Probability. Now you see, in this domain, x can take any value between 0 and 1. Okay, x can take any value between 0 and 1, and y should be greater than or equal to x in this probability statement. Okay, so let me show that to you. Let me show that to you by sharing my whole screen instead of. Now, I think you are supposed to see my whole screen, and I am just going to open a paint file to show you how this works. Okay, now, remember now, we have a three-dimensional function here, okay? Now, that axis belongs to x, and that axis belongs to y, okay? That axis belongs to x, and that axis belongs to y. And over the third dimension, which I'm not going to be able to show here, over the third dimension here, okay, imagine now we have the third dimension, which is coming out of the page. Over the third dimension, we have the joint PDF, fxy. But I'm not going to be able to show that to you. I am just going to show you the base of the distribution. Now here, both random variables are taking values between 0 and 1. Okay, both random variables are taking values between 0 and 1 here, and that is 1 here and 1 here, and we have 0 here. Okay, so the question is asking me this: what is the probability of x being less than or equal to y? So I am just going to draw the line for x being equal to y. So that line that I draw here is the line or equation of x being equal to y, and that region here is what? Which region? So if x is less than or equal to y, so it should be that region. So that region here is the region where random variable x is less than or equal to y. Okay, so in that region. So I am just going to integrate I'm just going to calculate a double integral of the joint probability density function to calculate the volume under the function in that region. So the integral boundaries should be limited to that region only. Now, let's just say when I'm calculating the double integral of the joint PDF, the inner integral belongs to integral operator y, and the outer integral belongs to integral operator of x. So we are going to start from the outer integral, okay? So let me write it here. So I have two integrals of the joint PDF here, and the inner integral operator is dy, and the outer integral operator is dx. Okay, so let me write it a little correctly. Okay, now in that region, in that shaded region where x is, so remember now in that region, so x is less than or equal to y. Now you see in that region, x is changing, x is taking values between 0 and 1. Okay, in all of the region, the least possible value that x can take is 0, and the maximum possible value that it can take is 1 in that region. So here it can take 0, here it can take the value of 1. Now, for a given x value, let's just say I have a given x value here. So for a given x value here, the possible values of y are changing between what? So the possible values of y are changing between x and 1. So the possible values of y for a given x value should be between x and 1. So if x is taking the value of x in the outer integral, then the possible values of y in the inner integral should be between x and 1, as you can see. And according to this inequality, actually, the outer integrals variables are free to go, so they are free to take any value. However, in the inner integral, we need to determine the possible values that y can take, and because of this inequality, y can take possible values from x to 1, because y should be greater than or equal to x. So that is the integral that I need to solve. Now, you may ask this question: what if I calculate that integral of the joint PDF in the reverse order? Now, instead of taking the integral, inner integral with respect to integral operator y, what if I calculate the inner integral with respect to integral operator x, then the outer integral with respect to integral operator y? Now, in that case, you are going to start from the outer integral again. According to the outer integral here, y can take again values from 0 to 1. So in this shaded region, in this gray region, the least and the maximum possible value that y can take is from 0 to 1. Now, let's just say for a given value of y, here, what are the possible values that x can take on? The possible values that x can take on are from 0 to y. Okay, so x is supposed to be less than or equal to y. So for any value in the outer integral, for any fixed value of y, the inner integral should be from 0 to y here. So in both ways, if you calculate that integral or that integral, you are going to end up with this probability. Either way works. So here, in the outer integral, x can take any value freely, but for a given x value, y should be greater than that, so y should be integrated from x to 1. Or in the other way around, if the outer integral belongs to y, y can take values from 0 to 1. However, because x is supposed to be less than or equal to y, for a fixed value of y in the outer integral, in the inner integral, x can only change from 0 to y. So because of that reason, we can calculate the both integrals. So let's just start with this integral. So the inner integral belongs to y operator, and y is changing from x to 1. Let's integrate it with respect to y. It becomes 3x squared y to the power 4. Remember now, if you integrate that function with respect to y, x is going to be assumed as a constant. And if you plug in values of 1 and x here, you get 3x squared minus 3x to the power 6. And when you integrate that function with respect to x again, you get x to the power 3 minus 3 over 7, x to the power 7. And by plugging in the boundaries of 0 and 1, you get 4 over 7. Similarly, if you calculate that probability in the other way around by first integrating the outer integral belonging to integral operator y and the inner integral belonging to integral operator x, in that case, you calculate the integral of the joint PDF with respect to x first, which is 4x to the power 3, y to the power 3, and plugging in x values as y and 0, you get 4y to the power 6. And now when you integrate that function with respect to y, you get 4 over 7 y to the power 7. Plugging in 1 and 0 values, again, you get 4 over 7. So in both ways, you are basically calculating the total volume under the joint PDF in that shaded region. So in that shaded region, the total volume under the function, under the probability density function, joint probability density function is 4 over 7. And in the remaining region, which is the white region, the total volume under the joint probability density function is 3 over 7. But unfortunately, you are not seeing the function here. It is in the third dimension. You are just seeing its base. Okay, the function is in the third dimension, which is equal to 12x squared and y to the power 3.